sine 2x.
Sorry, it's theta and 2 theta.
Say it again. Oh, yes, of course. I'm sorry. So this is 2 sine theta cosine theta. And if you remember, please remember, this is a basic identity or fundamental identity. 1 plus tangent squared equals secant squared. Yes, you can use a triangle, you can do whatever you want, but I'm recommending this method. Since I have tangent, I will say that 64 plus 1 is 65, which is secant squared. But secant squared is 1 over cosine squared equals 65. I cross multiply and determine that cosine squared is 1 over this cosine squared is 1 over 65. And when I take the square root, I get that cosine theta, it should be plus or minus, but since it's in the fourth quadrant, I know is 1 over the square root of 65. How do I know? I know because cosine in the fourth quadrant is positive. So I didn't have to put plus or minus. Yes?
So how did you get from tan theta to 1 plus tan squared theta? It doesn't square.
It's one of these two identities.
You're given that tan theta is just -8. It's not
Right.
squared.
Yeah, 64. Is that okay? So is this okay so far with cosine? Yes? Okay, so then I know that sine theta will be minus the square root of 1 minus this squared, which is 1 over 65. So then sine theta will be negative. 65 minus 1 is 64, will be 8 divided by the square root of 65. Yes, I should rationalize this, but I'm not interested in this answer. I'm interested in sine 2 theta. So I'm going to put everything in and see what happens. So for sine 2 theta now, I have 2 times sine, -8 over the square root of 65, times cosine, which is 1 over the square root of 65, which gives us -16 over 65. So that is sine 2 theta. Is this okay?
Yes, this is correct. So the question is like they asked you to find 2 theta as well, like in which quadrant is 2 theta?
I'm not finished.
Oh,
Oh, I'm not finished. So is this
yeah, it is.
okay? Perfect. That's all I needed. Good. Everyone, any questions on this? Okay, so now I need to determine cosine twice theta, which is, since I have cosine, I'm going to use the formula with 2 cosine squared theta minus 1. 2 cosine squared theta is 1 over 65 minus 1. So 2 minus 65 divided by 65, which is -63 over 65. At this point, I know for sure, since sine 2 theta and cosine 2 theta are both negative, 2 theta must be in which quadrant? Is that clear? We understand that? Okay, so then I will say 2 theta in the third quadrant. Now, I think you also said that we needed to determine,
Tan 2.
good. So then tangent 2 theta will be 16 over 63, and I'm done.
Okay, so the question is like if they just ask us like find tan 2 theta. So in that situation, like do we have to find sin 2x and cos 2x, or we just
No.
apply the other formula?
You can use the formula directly. I thought we needed to determine sine and cosine as well. Did you say that?
Yeah, that's
Okay.
what the question is.
Yes, you're right. So for tangent 2 theta, you can use 2 tangent theta over 1 minus tangent squared. So you have 2 times -8, so -16, and 1 minus 64, and you get the same thing as, I didn't write it, so it's 16 over 63. So 16 over 63. Negative and negative will make over 63. Yes, you're right. For this one, you didn't need to. But I determined sine and cosine because I needed to find the quadrant, and I thought that we were asked to find sine 2 theta and cosine 2 theta as well.
Yeah, so but our answer is positive, right? So tan theta is negative in third quadrant.
No. Negative sine and
sorry,
sine
yeah.
and cosine are negative.
Yeah, I got it.
Tangent cannot be negative.
Oh.
When we divide two negative numbers, we get a positive. Is that better?
Mhm.
Good. Excellent. Excellent question. Yes, Bailey, go ahead. Yes, of course.
All right.
Are we finished? Did you have something else?
So from here, can we find like which quadrant is this?
What do you mean? 2 theta?
From this answer, like 16 over 63.
No.
That's
No,
what
if I
was-
tell you tangent is 16 over 63 and I ask you which quadrant is the angle, you'll say, I don't know. It could be in the first or it could be in the third.
So it means ultimately we have to find sine 2x.
Yes.
To find
Yes.
quadrant.
Yes. Yes, because tangent is positive in 2 quadrants and you don't know.
Right.
Both positive, both negative. Yes, please. Did you have something else, Imran?
No, that's
Okay, yes, please,
Then
Bill.
will be simplifying the expression.
Yes, I'm ready.
1 minus sine squared x over cotangent squared x plus 2 cosine squared x.
That's it? So it's like over 1?
Yes, ma'am.
Can you check and see if I copied it correctly?
Perfect.
Okay, thanks. Okay, so we want to fully simplify this. My first thought is that I should change the numerator into cosine squared. I should factor out cosine squared and see what happens. Cotangent is cosine over sine, so this is sine squared over cosine squared plus 2. And that will be cosine squared, the least common denominator. This was, there was a 2 in here, right?
Yes, ma'am.
Okay. So I'll have sine squared x plus 2 cosine squared x over cosine squared x. And sine squared plus cosine squared is 1. And I have a remainder of a cosine squared. I wouldn't take it any further because I can't.
I have a question.
Yes.
How come you wouldn't get common denominators for and do like cosine squared x to both sides? Like, because it's cosine squared x over cotangent squared x plus. So why wouldn't I make the other denominator cotangent squared x so I can add them? And then I can take like.
Here's why. First of all, I don't have anything against tangent, cotangent, secant, cosecant. But it's better to keep it simple. Keep it simple means using sine and cosine. That's number 1. Number 2, if I can factor and simplify the expression before I do anything else, of course I will. Why would I multiply the cosine squared by cotangent squared and then ask myself what now? Since I see from the very beginning that cosine is in the way, cosine squared is in the way, and I take it out. Then, instead of cotangent, I have cosine over sine, and when I flip it, it's much easier even to look at, right? Doesn't poke you in the eye. Cotangent does. So sine squared over cosine squared plus 2. Now here, I find the least common denominator to be cosine squared. I do multiply 2 by cosine squared. And I do get a much easier situation to work with. The cosine squared goodbye. And then I have sine squared plus cosine squared plus another cosine squared. But sine squared plus cosine squared is 1. And I have a leftover of a cosine squared. I don't have anything against cotangent and tangent and secant and cosecant, but if I can simplify down to the simplest possible ones, I will always do that. It's an option. Now, the more we practice, the more time you spend on this, you will develop your own style, which will be fine. Whatever works for you. Yes, sorry, I figured it out. Okay. Good. Other questions? It was a very good question. Thank you for bringing that up. Anything else? So there are many ways to a particular final simplified form. You choose the one and I'll be fine. As long as it's all legitimate step by step, it doesn't matter. I'm trying to show you a way that I think it's shorter, but you may be able to find an even shorter one. And I would like you to take the time and find the shorter one if there is one. Because that's what it's all about. Okay, what was I doing? I'm trying to review for the final. Ready? I like to list some topics that I would like us to, we may not be able to review everything, so I would like you to pick and choose. So, final exam topics. Of course, we go back to absolute value. If you remember, we were adding or subtracting two absolute values. So that's one type. We all remember that, right? Then we factored expressions like, I don't know, 1 minus x to 1/3, or 2 plus x to 2/3, and then we will simplify in parentheses. This is important for Calc 1. This is important for Calc 1, both these. Then the factor theorem, together with the remainder. What was this all about? When we divide p of x by x plus a, p of a, I should write negative because I want to keep it as p of a. So x minus a, the denominator. You know, we always have to change the sign, whatever that is. If it's x minus 3, we put 3. If it's x plus 5, we put negative 5. So, but I have to write it as minus. So p of x over x minus a, if we are looking at this division, p of a is the remainder. If p of a is 0, then what? Excellent. X minus a is a factor of p of a, of p of x, of course. Perfect. Rational equations. Rational inequalities and polynomial. Polynomial and rational inequalities.
What is that again? Is that with the chart?
Exactly, yes. Or your own method. Or your own method, I accept it. Difference quotient. This is extremely important for calculus. This. All these are major topics in Calc 1. Domain of functions, major topic. Sequences and series, no, it's not for Calc 1. Reducing powers of the trig products, sine squared, sine to the fourth, cosine to the fourth, no, it's not for Calc 1, but it's important. Domain. Models with linear, quadratic, log, and exponentials. So we had word problems with a relationship between two variables is linear, find the equation of the line, and determine something about it. We throw a ball up in the air. This is the trajectory of the ball. Find the maximum, the minimum, find where it hits the ground. That's with quadratic. With log and exponential, we had plenty. We had the ruler problem, I think. We had Newton's law of cooling. We had exponential growth and decay. We had the logistic growth model. All these will be given to you. So these will be given to you, even logistic, of course. What else we did here? Finding the amount, the accumulated amount if we deposit an amount of money for such and such number of years and such interest. Also with exponential. Right? That's all we had. What else? Yes. Graphing piecewise defined functions, polynomial, exponential, so graphing. Extremely important, very important for calculus. The next one, very important for calculus, graphing. Super important, log, exponential, polynomial, rational, piecewise. Extremely important topic for calculus. I cannot think of anything else. So now from trig, exactly what we just reviewed. So for trig, finding, let's say, sine 2x, etc. Finding sine x over 2. Finding, let's say, sine of tangent inverse plus cotangent inverse of two different numbers. Reducing powers. Only on something like this, or cosine to the fourth, or sine squared, cosine squared. These are involving enough. They cannot be higher powers than that. It will take you 20 minutes, and I don't want that. Absolutely not. Trig equations. Law of sines and cosines. Say it again, sorry.
Verifying or simplifying? For trig equations.
We are not verifying anything. We've never verified the trig
Like
equation.
right-hand side and then left-hand side. Like that.
Identities.
These are not equations, you're talking about identities.
Uh-huh.
Good, identities. Yes, trig identities, trig equations. Law of sines and cosines. You did very well. Everyone did very well on that test. I can't think of anything from trig, really. That's it. What we covered last time and what we looked at last time. Under equations, did I put equations? I don't think I did put. I only said rational equations. I want to add here exponential, log, radical. Okay, so we have that. And from conic sections, and that's it. And a little sequences, very simple, very short. Sequences and conics. One example, one example. That's it. Yeah, I say that's it, but it's huge, right? So all these are extremely important. Or these are extremely important. These are important. These are important. But all these that I checked are super important for your next class. Bless you. Okay. So since we looked at all these, now you tell me what you would like to go back to. So let's choose. Yes, please.
Could you go ahead the equations, the radical, and what you just added?
The exponential, log, and radical?
Log
Which
and exponential is fine. Can you do one for rational and radical?
Rational and radical. Okay, very good. So let's take a look at radical equation. Which page am I on? 6. Okay, so let's say x plus 13 equals x minus 7. So this is a radical equation, and we are solving for x. The radical is, there is only one radical. It's isolated on one side, so we can immediately square both sides. So then I have x plus 13. I'm begging you to always write 3 terms when you square binomial. Otherwise, you make me do like my colleague, scream in a pillow at home so I don't bother the neighbors. So that was a joke. So minus 15x and plus 36 equals 0. And then we will factor x minus 12, x minus 3. And we get 12 and 3 with a big question mark, because we do have to go back and check.
Do the table.
And obviously 3 does not work because 3 minus 7 will be negative and this side is always positive. So 12 will work, but 3 will not. So that is a radical equation. Any questions on this one?
So
Yes?
every time when we get two answers, like you have to go back in the original equation.
So, when I have an equation and I add 2 to both sides, if I choose to not to check the solution, it's okay. If I subtract 5 from both sides and I choose not to check the solution, it's okay. But if I square both sides, if you remember, possible extraneous solution may pop up. Solutions that do not verify the original problem. Because squaring both sides is not 100% legitimate. I have no choice, because I have no other way. But I have to keep in mind that the new equation may not have the same solutions as the one I started with. But if I add 5 to both sides, the new equation will definitely have the same solutions with the previous one. If I move terms around, if I divide both sides by 5, nothing will happen. This equation will have the same solutions with this one. But when I square, it's not guaranteed. It's not 100% legitimate operation. And I have to keep that in mind, and I have to go back and check. But don't forget what you want to say. Do not check in that square. All solutions will work in the squared one. You have to check in the original one. In this one, I check 3 and it doesn't work, and I check 12 and it does. If you check them in the one with the square, all solutions will work.
So is there any way like we can put the restrictions first and then we solve it?
Yeah. When I learned this a million years ago, this is how I was doing it. This is another system that I had to adapt to. I'm not saying it's better or worse. I'm just saying it's a different system, but you're right. Yes.
So what is the restriction in this case?
Yeah, you can state the restrictions from the beginning, but careful. On such an equation, you have to state restrictions on x plus 13, but we also have to state restrictions on x minus 7, because x minus 7 has to be greater than or equal to 0, as well as x plus 13 greater than or equal to 0. So I kind of prefer this new, sort of, for me, new method.
So let's say in this question, if you ask us to find the main edge, then for this.
Yes, so in this case, for the function, if you're only looking at the left-hand side, then you have to write that x plus 13 is greater than or equal to 0. But inside an equation, it's a different story. The other side has to be positive. It's a very good question. So, if you want to do this, you have to write this. These will be the restrictions for that equation. So x must be greater or equal to negative 13 and x must be greater or equal to 7. That's why both, right? So the common domain will be then 7 to infinity. So that's why only 12 is acceptable and 3 is not. So just keep that in mind. Now, if you have negative the square root, then it's a different story. You have to multiply first by negative 1. So I kind of really got, I bought into the other method of checking, thinking in terms of, oops, I applied this method, but it's not 100%. I think that's a better, in a way, than doing this. Now, when it comes to log equations, I strongly recommend, not impose, but strongly recommend stating the domain, then going back to check. But it's pretty much the same thing. Very good question, thank you. Okay, what was I doing? Oh, rational, here. I wrote the final exam for another class, and I have here a rational equation. Is this something you would like to solve? Okay, very good. Good, so this is a rational equation. I recommend this method. However, as I mentioned many times before, I accept any that is legitimate, right? So what I recommend is this, moving everything to one side, stating two restrictions, finding the LCD, if you forget the equal symbol and 0, you're not solving, you're only changing the equation to an expression and you're not going to get anything. So then, x plus 2. Do not forget about the adjustments of the top. You cannot simply copy 5 plus 2 minus 3. That would be incorrect, right? We know that. So this one needs an x. This one needs an x plus 2. But this one needs together. And I will write them up here multiplied because it's easier for the next step. So now we write the numerator as being 5x plus 2x, very good, plus 4, minus 3x squared minus 6x. And now I know I showed you to put 1 and then cross multiply. I think we can grow from there. Here's how. A fraction is 0 only when the top is 0. You can stick with that method, of course. You can put over 1 and then cross multiply. You'll get the same thing. But now I think we should move on from that and say a fraction is 0 only when the top is 0. In descending order, negative 3x squared plus x and plus 4. I multiply both sides by negative 1. If you care to factor, factor. If you don't care to factor, it's fine too. 4 times 3 is 12, 12 times 4, and 6. So this is x equals 1 plus or minus 48, 49, 7 over 6. So x equals 8 over 6, and x equals negative 1. My first thought, of course, is here. But none of them is 0 or negative 1. So I'll say yes. Any questions? Okay, next topic. Anything else?
Could you
Yes.
please show us like the graphs like in which we find the vertical asymptotes and then we draw the graph.
So you want a rational function
Yeah.
to graph?
Yeah.
Yes, of course. Do you have one in mind?
No.
You want me to choose?
Yeah.
You want one with a hole?
Yeah, hold on.
With a hole. Okay, so this is a rational function. We're asked to present everything about it. And you know, it's a long list of everything. So the first thing we need to do, obviously, we have to find a domain. X and Y-intercepts, horizontal, vertical asymptotes, and possible holes in the graph. I know that x cannot be 0 and x cannot be 4. Only now I can simplify. And the simplified form is x minus 1 over x minus 4. This is a tremendous important type of problem for Calc 1. We will enhance this problem with something that we learn in Calc 1. However, you will remember this when you see it. Okay. So it's negative infinity to infinity. It's 0, it's 4, undefined, undefined. However, x goes away, so x equals 0 is a whole. 4 stays, x minus 4 as a factor stays, so then x equals 4 is a VA. This is type 1. By type 1, I mean the horizontal asymptote is the leading coefficient over the leading coefficient. So that is 1 in both cases. 1 and 1. Y equals 1, horizontal asymptote. In order to determine the numbers left and right, I have to plug in 0 here in the simplified form. 0, 0, negative 1 over negative 4 is 1/4 on both sides. Here it's a VA, so I know it's infinity, and I will check with 3.9 and 4.1. With 3.9, I get positive over negative, which makes it a negative. With 4.1, I get positive over positive, which makes it positive. This function cannot be symmetric with a hole at 0 and a vertical asymptote at 4, but I would put that in writing. The only thing that I need is the x-intercept. There's no y-intercept because I cannot plug in 0. But there is a x-intercept. When is this fraction 0? When x is? Excellent. Be very careful where you put it in. So, final thing that I would write is that f of negative x does not equal f of x, and it does not equal negative f of x, which tells me that you know about symmetry, not symmetric. And now when I graph the function, I have to start by graphing the asymptotes. So there are two asymptotes, one at 4, which is vertical. This is x equals 4, and one at 1, which is y equals 1. I have to create this point 0, 1/4, very difficult. Let's say it's here. I have 1, 0, and from here it all makes sense. From 1, crossing at this, going through this hole, crossing at 1, 0, going towards negative infinity. No problem whatsoever. And on the other side, no problem, from positive infinity to 1. So this is the graph of x minus 1 over x squared minus 4x. Good. Next topic. Okay, are we okay with the absolute value expressions? How to simplify them? Is that okay? Is it okay about that factor? Are we able to factor out something and then simplify the inside? We've done that a lot.
We just do one part one.
Right. So do you have one? I don't have the that handout. Let's choose one from the handout. If you have the handout, we can choose. It's posted. It's posted. I can look it up. You don't have to. It's posted. I can find it in the blink. Got it. We solved all of them. We determined all of them, but it doesn't matter. Okay, we did all of them, I'm sure, but let's do 9. I don't know if we did 9, bless you. Maybe not, maybe we did not do 9, let's do 9. So in 9 I have x negative 1/2 x squared minus 4 to negative 3/2 times 2x plus x squared minus 4 times negative 1/2. Oh, raised to power negative 1/2. Okay, so again, this is what I would do, and you decide for yourselves what you would like to do. But in my case, I want to simplify these. I don't like the way they look. I know that this is the only common factor in both, but I like to rearrange the whole thing before I pull it out. So 2x times negative 1/2 is negative x times x is negative x squared. And then x squared minus 4 raised to negative 3/2, and then x squared minus 4 raised to negative 1/2. So the only common factor is x squared minus 4, and now we have to decide upon this power. So what is the power? Well, the power has to be the smallest of the two. So you can have something to pull out from. So you cannot pull out negative 1/2 because it's larger than negative 3/2. So you have to pull out the smallest, which is power negative 3/2. So if this is out, what is left is just negative x squared. I reach the positive now, and then from negative 1/2, I subtract negative 3/2, which is negative 1/2 plus 3/2, 2/2, which is 1. So that's how I get this. So then these two go away. Negative 4 goes in front, and this goes to the denominator. There are two ways of writing this. One way would be the square root of x squared minus 4 to the third. And the other option, which I personally prefer, but it doesn't really matter, it's not a big difference, x squared minus 4, the square root of x squared minus 4. I did not contribute to this document. I'll go back in a second. I'm just curious to see. I don't know who wrote solutions, but now I'm curious to see what they wrote. If the answer should be here. Which number was this?
9.
Number 9. Yeah, so they just wrote it in the denominator. They did not separate, which is fine. This is fine. It doesn't really matter, but when you get to Calc 1 and you're trying to study the sign of a derivative, this is what you need. This is easier, I would say, to study. But that's fine, either way. Good. Next question. Next topic. Yes, please.
What do you mean by domain of functions?
What I mean by domain of functions?
Yeah, can you go?
Yes. So here it is. So we're asked to find the domain of this function. It's a function determined by adding two functions. Both have restrictions. This one has x squared minus 1, and this one has x plus 4. Now, if one or the other is in the denominator, then you cannot write the equal symbol. It will be just strict inequality. So now I have to intersect. I have to solve the first inequality. I have to solve the second inequality, intersect, and find the common domain. So let's start. The top one. Remember, x squared minus 1 greater equal to 0, you have to factor it. And you have to use whatever method you prefer. I recommend this one, mostly because it's easier for me to explain and because I'm using it in all my classes, but it's up to you. So I have negative 1 and 1, 0 and 0 and 0 and 0, and they both have the same sequence of signs. So then positive, negative, positive. So for positive, I have to choose this. So the first inequality will have solutions between negative infinity and negative 1, union 1 and infinity. The other one has x greater than or equal to negative 4 or negative 4 to infinity. Now, it's not difficult to find the intersection, but for me to explain, I would like to graph it. You may be able to see it without graphing it, which is great, but it's easier for me to explain what I'm doing if I graph the solutions. So the first one will be between negative infinity and -1, and the other one from 1 to infinity. And now the green one is greater than or equal to -4. So obviously we see purple, or it's not clear, but this is green, this is purple. We see both colors here as well as here. So the domain of the function, that is the sum of two radicals. So the domain of f is -4, -1, union 1, infinity. Extremely, extremely important for calculus.
So this would be the one that we, is there another one?
Another one what? What? I don't know how to answer. Another one,
Like, are there
be more
any-
specific, I don't know how to answer.
Are there any more functions like that require like work to find domain?
All of them, yes. Anything that is a ratio, anything that has a log in it, anything that is a sum of logs or difference of logs, anything that is a ratio, anything with radicals, yeah. Infinite. Yes, infinitely many different ones.
So is there any case like in which we only use the greater than sign, we don't use equality, like greater than equal to?
Yes, that's what I was just saying that, yes. So for example, if I have a function that is 1 over the square root of x minus 1, I can only write this. I cannot write the equal symbol. So the domain of this function will be 1 to infinity.
And if it is in the numerator,
If it's in the numerator, it doesn't matter, it can be 0.
no, then you can use the equality.
Yes. So for example, yes, of course. So if I have this example then, then the two restrictions are x plus 4 greater than or equal to 0 and x minus 1 not equal to 0. So the first one is, the first says domain is between -4 and infinity. And the other one says x not equal 1. So then the common domain, or the domain of the function f, in other words, is -4 to 1 union 1 to infinity. Extremely important for calculus.
And if we have under root on top of this x minus 3,
If you want the square root on this one,
yes,
okay, then you would have to write,
x minus 3 greater than or
oh,
greater than equal to?
wait. So
Yeah, you wrote
I'm
one.
sorry. I wrote 3 and then I wrote 1 over there, sorry. It's 3. Okay, so if we want the square root of x plus 4 over the square root of x minus 3, okay, then we have x plus 4 greater than or equal to 0 and x minus 3 greater than 0. From here we have -4 to infinity, and from here we have 3 to infinity, and the intersection will be, common domain will be 3 to infinity.
But here we have parentheses or like the square bracket, because 3 is not included in this.
3 is not included. I'm thinking of the next, no excuses, of course, no, not included. My brain is already on the next topic that I want to present, or whatever you choose, so my apologies, of course. 3 cannot be included. Strict inequality, parentheses. Strict inequality, parentheses, absolutely. Okay, next topic.
What did you want to present?
I have no idea. My brain says, okay, time, present as much as possible. So you choose whatever you want.
We do an absolute value.
Yes.
Can we do subtracting? 'Cause I think
Yes.
subtracting is not-
Yeah, can you make one up? I think we did like 10. Okay, so can anyone make up with the difference?
What would be the maximum power for this function? Any power?
Say it again.
Like what would be the maximum power for this function? Like,
Well, it's a very good question. If we put an absolute value on a quadratic function, it will take you 20 minutes to finish it. So let's stick with linear.
Okay.
Or we use just one in absolute value, and we use a quadratic function. It's up to you.
like quadratic.
But we can have, if I put a quadratic function or two quadratic functions with two absolute values, it will take forever.
No, should we
And I'm
expect-
not trying to
Like, should we expect like these kind of
linear. So let's use linear or just one absolute value with one quadratic. It's up to you.
Let's just do linear.
Okay? So anyone?
3x plus 2. X plus 4.
Very good. So we take the absolute value of 3x plus 2, and we get 3x plus 2 for x greater than negative 2/3, or negative 3x minus 2 for x less than negative 2/3. In the same way, we have x plus 4, x plus 4 for x greater than or equal to negative 4, negative x minus 4 for x less than negative 4. This is all based on the fundamental definition, formal definition of the absolute value. So remember, we have to write 3x plus 2 greater than or equal to 0. I already solved it. And if this one is greater than or equal to negative 2/3, this must be the other side. But be very careful, because if the leading coefficient, which we did not choose, but we can still correct, we can make a change. If the leading coefficient is negative, these two will not be in that direction. It will be in the opposite direction. So be very careful. Do not assume. Would you like to make this with a negative leading coefficient? Okay, then. So then this is negative and this is positive, but then this will change, because negative x plus 4 greater than or equal to 0 means this, which means this. So I'm going to have to correct that because of the change we made. So please do not assume and write without thinking, like I just did a couple of times today. I said one thing and I wrote another. My apologies. Okay, so this will be less than or equal to, and this will be greater than. So only now if you're using the table, if somebody showed you a different method or you read in the book a different method, we are fine. Whatever works for you. And the absolute value 3x plus 2 minus the absolute value of negative x plus 4. Okay, so we have two key numbers here. Negative infinity, negative 2/3 for infinity. I only copy this information in the table. I'm not doing anything, I'm not changing anything. So it says greater than or equal to negative 2/3, write this. But less than negative 2/3, write this. For less than or equal to 4, write this. For greater than 4, write this. Now all I have to do is just subtract the second one. I recommend writing it. So negative 3x minus 2, but minus this will be plus x minus 4. 3x plus 2, but minus this will be plus x minus 4. And 3x plus 2, but minus this will be this. Okay, so finally negative 2x minus 6, 4x minus 2, and 2x plus 6. So we did that. Everything is fine, but we have to write the final answer. And in the final answer, we will have to have three options. for 3x plus 2 minus negative x plus 4. One option is negative 2x minus 6, the second one 4x minus 2 and 2x plus 6. And now we have to refer back to the interval. So less than negative 2/3, between negative 2/3 and 4, and greater than or equal to 4. Remember, you decide where you put the equal symbol, but only once. So for negative 2/3, you have to put the equal symbol either here or here, not both. For 4, you put the equal symbol either here or here, not both.